All right, we're live. Thank you guys for joining us. Sorry for the delay in getting started. We've got a really special session today. Lots of awesome guests and an awesome moderator. So with that, I'm going to hand it over to Kumar to kick things off.
Well, Harrison, thank you so much for having me. Thank you everyone for joining this discussion. Sorry for starting a little late. I think that was technology problems on my end, but I'm super excited about this conversation. I'm thrilled by how many people are joining it. And for those, I think the core goal is, discussing the intersection between the huge amount of interest that's happening around AI, machine learning, large language models, and tools specifically like LangChain, and the topic of education. I worked in the Obama White House as President Obama's ed tech lead for almost 8 years. Was there for lots of important developments in education. But I have to say that I think the role that machine learning can play in education has potential to be the biggest thing that will happen in our career. And so I'm excited about its potential, but I think there's a lot of open questions. And I think this developer community is going to be a big part of how do we start to figure out these answers. So as Harrison said, I'm at Schmidt Futures. It's Eric Schmidt's Science and Tech Foundation. I'm one of the vice presidents. I'm also the executive sponsor on a program called Learning Engineering, which specifically focuses on how advancements in machine learning can improve our understanding of human learning and improve educational outcomes. We have been incredibly, the work that we've done in this program has actually lasted over a couple of years. So we've been enthusiasts about the potential of these technologies for some time. But I would say the past 6 months have been quite revelatory and just a huge amount of public interest and also the speed of development. And I think, one of the key questions is going to be, what are going to be the user communities and tools that will develop in this area? And I have to say that, we were definitely fangirling and fanboying when Harrison agreed to do this, because we'd been talking internally about how tools like LangChain have the potential to create these new scripting languages that can really help create much more powerful tools on top of these LLM models that are popping up. So why don't we first start with just a little bit of context? Some people I think will be very well read up on this and some won't. We have a bunch of people who are from the education community and the ed tech community who are joining. So Harrison, not to belabor, but it would be great if you gave a little bit of what is LangChain and why are people excited about it in the context of large language models?
Yeah, absolutely. And thanks for thanks for joining. As mentioned before, LangChain is a framework for developing LLM applications. So we're a developer toolkit. We've got a package in Python and a package in TypeScript, and a lot of the things we provide in terms of making it easy to develop LLM applications involve connecting it to other sources of data and computation, and a lot of tips and tricks to really eke out kind of the best performance of language models, whether that be chaining or different types of reflection or things like that. So, language models are this incredibly powerful new technology, but they still have a bunch of shortcomings in terms of not knowing about your own data, not being connected to other sources of up-to-date data, up-to-date computation, and not being really personalized as well. And so, as we start to talk about education, and I'm sure we'll hear from a bunch of presenters, there's a lot of difficulties in just using language models. Some of them can be, lack of factual understanding, the responses can sometimes be hallucinated or made up. And then another big part is personalizing it to a course, to a user's learning level, to anything like that. And so LangChain provides a bunch of developer tooling to make that type of personalization as easy as possible.
Yeah, it's super powerful. And one of the things that I find so interesting about it is that it's not just a concept. People are actually using LangChain in lots of powerful ways. So not only did you build it and put it out there, but it immediately started to get a ton of use and people started to build it out. So I think, one of the things that I'll sort of recommend, we have all these great folks who are participating, is, folks, as we start to go through these different use cases, definitely drop in your questions along the way, but also what are ways you're using LangChain, and if you're doing anything specifically on LLMs in education, feel free to drop that a little bit in the chat, and we'll follow along, both on experiences you're having, and then questions you might have that we'll have in a active Q&A. And I also want to call out Anjali on our team, who helped actually set up this conversation. So why don't we do a quick, we're going to have 3 quick presentations just on how people are starting to use this stuff, just to help ground us. And then we'll go into a Q&A, both on what those presentations were about, any questions you dropped in the chat, as well as ideas Harrison and others have. So why don't we go through those? First up, let's have Joshua Ling, who's the CEO and co-founder of Podzy. Joshua, tell us what you've been working on and how the community can benefit from those early experiments.
Sure. Can I actually share my screen?
Given that I struggle to just sign on, I might not be the best answer. So if you can figure it out, then sure.
All right, perfect. Can everyone see my screen? I see mine, or I see mine on the broadcast. I'm going to assume yes.
I can see it, Josh. You're good.
Great. Cool. Yeah, my name is Josh, like Kumar mentioned, and I am the founder of Podzy. I'm a former middle school math teacher turned software developer, and 2.5 years ago, I founded Podzy, which is a nonprofit edtech dedicated to improving student learning outcomes and empowering teachers by making it easier for them to utilize research-backed strategies in the classroom. So to do this, we've built a free web app that allows teachers to provide personalized review for students throughout the school year. As a quick overview, how this works is we give each student a personal deck, and as they complete assignments on Podzy, every question from the assignment then gets inserted into the personal deck. And then we have a spacing algorithm that powers this deck and decides when the optimal interval between questions is to when students should review a question again in order to maximize their likelihood of retaining what they've learned. Specifically, our app's actually inspired by a 2014 paper from Robert Lindsay and his colleagues. And in that paper, they showed that personalized spaced out review over the course of a semester, at least, can actually improve learning outcomes by 16.5% in classrooms. So currently, we've actually started experimenting with leveraging large language models in our web app. About half a year ago, we first started by allowing teachers to generate questions based on background text that they provide. And we're just hitting OpenAI's Turbo 3.5 chat model. So as an example, here we are pasting in text about plant and animal cells. It generates 5 questions that teachers can select from. And then once they've selected the questions they want, we hit the endpoint each time to generate answers again. And then once they've actually decided which questions they want for their assignment, they can either add it or discard it. Some other features that we've been working on includes a chatbot as well. It's an alpha feature that's not actually available to teachers and students yet, but the goal here is to build something similar to what Khan Academy is doing with Khanmigo and allow students, after they answer a question, to ask questions to a tutoring chatbot to address misconceptions, ask clarifying questions, and overall just get a deeper understanding of the underlying concepts that the question was assessing them on. So as you can see here, what we've started with are some lower hanging, perhaps more obvious implementations of large language models that the Turbo 3.5 chat model from OpenAI might just generally be good at. However, as we start developing other LLM-based features, we're running into use cases where we need these base models to be more powerful and more accurate. And that's where LangChain has come in. So we've been exploring LangChain recently as a way to give the Chat Turbo 3.5 model access to specific tools. And I think to explain how we're thinking about using LangChain, I want to walk through a specific example. So specifically, right now, during the summer, one of our main priorities is to make Podzy work well in math classrooms. And right now, it's currently not optimal for math classrooms because, as you might imagine, if a student sees this specific question over and over and over again in their personal deck, they might just memorize the answer -36, rather than actually rather than actually practicing whether they know how to solve a multi-step equation. So the way that we're thinking about using large language models to address this problem is to generate variations of this question automatically when a teacher creates this question. So for example, we might automatically generate a question like 5 times x plus 7 equals 2x minus 40 or something similar, and therefore provide or prevent students from memorizing the answer. However, unfortunately, when generating these variations, we're realizing that a lot of times they're just not great at solving math problems. So for example, it might just generate an inaccurate answer for a problem here. We've tried things like, chain of thought prompting in order to make it more accurate. So for this specific example, by adding this, think through this step by step, it actually did improve it. However, it didn't seem to work that well when we started using larger numbers as well. So actually, where we're currently at is we've been looking into using like the program-aided language models in order to solve this problem. So just a quick overview for those of you who might not be familiar with program-aided language models. This allows the language model to represent a math problem as a computer program, and then it actually gives it access to a code interpreter to execute it and then calculate results. So at the moment, we're actually iterating a lot within the LangFlow library, and we're just trying the different tools. We've tried like the basic calculator tool, this program-aided language model tool as well. And then I think we're also hoping to try out the Wolfram Alpha tool to see if we can get consistently accurate results when generating answers for these questions. So yeah, if anyone has any suggestions or thoughts on how to best implement this, I think this is something that we're really interested in learning more about. And looking ahead, well, if you have thoughts on how we can improve this is my email. I'd love to, sorry, that should actually be Podzy, not that extra D there should not be there. But yeah, looking ahead, I think we're excited to try using LangChain for like much more sophisticated and powerful things, like giving access to like SQL queries against our database in order to serve as a much more robust and powerful teaching assistant so that teachers know where to target and help students specifically in different areas. Cool.
Super interesting. And I love all the questions that everyone is dropping, as well as the different ways that they're learning. I mean, Podzy is a great example. We met, Joshua and his team a couple of years ago, and they've been really building out this idea of taking a core idea that exists in the learning science space, which is the role of spaced repetition, and then adding a lot of engineering on top for how would you actually bring this to use for teachers. And obviously, there's important questions in education, like obviously these LLMs aren't particularly good at math right now, but they might be quite powerful in, building feedback loops to students, which end up being very important to learning. So why don't we do next up, Wesley? Wesley, do you want to talk a little bit about your work?
Sure, thanks. Let me share my screen. All right. Hello, everybody. My name is Wesley Morris. I'm a second-year PhD student at Vanderbilt, and I'm really excited to tell you about some of the work that I've been doing with a project called Intelligent Textbooks for Enhanced Lifelong Learning, or ITEL. I'm part of a lab called Lear Lab at Vanderbilt, and we're part of an institute called AILO, which is an NSF-funded institute for adult learning. And the project that we're working on right now is called ITEL, Intelligent Textbooks for Enhanced Lifelong Learning. So first, I'm going to give you all a little bit of an overview of our project. And then after that, I'm just going to walk you through some Jupyter notebooks to show you some of the workflow that I've used recently using LangChain. I've worked with machine learning models, with large language models for about 2 years, but I am brand new with LangChain. I've only been working with LangChain for about 2 or 3 weeks. And so I'll walk you through a little bit of my learning journey here with LangChain. So what is ITEL? Everybody's familiar with traditional textbooks and digital textbooks. But an intelligent textbook is something that can interact with the student. It can recommend activities for the student and provide feedback to the individual user. So ITEL is not a specific textbook. The whole point of ITEL is that it is domain agnostic. It's a framework for generating textbooks. In short, a developer can provide any kind of informative text in a correctly formatted MDX file, and ITEL will automatically generate an intelligent textbook based on that content. So for now, we're using a textbook from OpenStax for our prototype. And the main user feature that we have in the textbook right now is a summary writing at the end of each section. So the user will read the section, and then at the end of the section, they'll write a summary. And I trained 2 long-former models to evaluate the summary on content. In other words, how well does the summary reflect the content of the source? And wording, in other words, how well does the summary paraphrase the source and the type of wording that it uses? So we provide feedback to the students currently in the current textbook. It goes through a junk filter. If it finds out that it's been plagiarized, it'll get stopped. If it's a low quality summary, we'll fail it on wording or content. And then if it's a good summary, then it will pass the summary. One special thing about ITEL is that it's designed specifically with the needs of researchers in mind. We're researchers. We're not directly in the education technology business. And so as we're designing it, we're thinking constantly about how we can use it for research. So we're collecting data on the user behavior as they use the textbook. We're collecting keystroke logging data as the student types the summary. And then we're also collecting attention to text data. So how long does the user spend looking at each subsection of the textbook? And so that's where we are so far, but we are planning on adding new features to the textbook. And I'll show you what I've been doing here. Okay, so one of them is question generation. And I started doing this before I found out about LangChain. And I just want to show you what a mess this was before. I'm not going to put you through the torture of walking you through this, but all I'm trying to show you is what a nightmare of regular expressions it was to do output parsing on the output from OpenAI's ChatGPT. So moving up, LangChain offers something called a prompt template, which makes it a lot easier to feed the prompts into the large language model. And so that made it a little bit easier. And then finally, they offer a feature called response schemas. So in this case, we're generating recall, summarization, and inference questions for each of the subsections of the textbook. And using the response schema, we can generate a question, a correct answer, and an incorrect answer for each of the subsections. And later we can use the output to train another model to be able to tell correct answers from incorrect answers. So we have 2 problems. One is generating the questions, and the other is evaluating the answers. And so using the response schema, we can do a prompt template and then iterate through each of the different subsections to generate nice little JSONs that we can easily convert into a data frame. And so this has kind of saved us a lot of time and effort. And we can create a data frame like this that creates the question, a correct answer to the question, an incorrect answer to the question, and so on. And it can all be done automatically, which is our whole goal with ITEL, is that it can be domain agnostic and be entirely automatic based on the content provided by the developer. So output parsing is one of the uses that I've found for LangChain. The other that has been really convenient is using the vector stores for embeddings. And this is a much shorter and cleaner notebook. So I'll walk you through this just to show you how easy it is to generate a vector store and use it for looking at similarity between the summary and each subsection of the textbook. So the point of this is that we'll be able to take the summary. If the summary fails the content test, we can tell the user which subsections they might have glossed over or missed and redirect the user back to those subsections. And then also, in terms of research, we can look at the relationship between time on text for each of the subsections and which subsection the summary is most similar to. So all you have to do is load the embedding model. I used, what did I use? I used the mini LM because it's faster and more convenient. And then just generate embeddings for each of the subsections in the textbook. And the inference is just this. All you have to do is put it in, and it'll give you the most similar subsection and the similarity score. So those are two of the use cases that I've found with LangChain in the past couple of weeks. But I think where LangChain is really going to come in handy is when we start integrating intelligent tutors, and we can start fine-tuning chatbots basically on the content of the textbook. The agents that are provided by LangChain are also look really exciting, and I'm super psyched to continue working with LangChain to develop ITEL and to make our textbook better and better. Here's our lab, and that's all for me.
Amazing, thank you so much. I think it's like exciting both for like the quick uptake that you're seeing, but then also some of the use cases, summarization, bots attached to certain bits of material. I think there's like a ton there. So why don't we go next to Perpetual? Perpetual, you want to talk about your work?
Sure. Thanks so much, Kumar. And thank you all for having me. Very excited to talk about a little bit more about the work we do at the Learning Agency Lab and how it intersects with large language models. So I'm going to try sharing my screen as well to help facilitate this conversation. I hope you all can see my screen. Okay, cool. And so as we're thinking about how do we leverage large language models and also LangChain as well in solving educational problems, I will say that the work that we do at the Learning Agency Lab is probably slightly different from what we've seen so far with Podzy and with ITEL. We aren't necessarily developing a specific product or tool, but we believe in creating data sets, creating data science competitions, and creating an environment to attract innovators in data science and machine learning to leverage the power of large language models to solve critical problems in education and address important research questions. So at a high level, where we connect with large language models is through these open data sets that we build and release, and through these data science competitions that we run based on these data sets to define critical educational challenges that we believe the latest innovations in NLP and in large language models can address. So the real meat and potatoes of our work at the Learning Agency Lab is through these open data sets and data science competitions. So at a high level, what we do is we try to partner with education-focused organizations. They can be a nonprofit, maybe even a public agency, who have specific research questions or specific data that they believe AI, machine learning, NLP can use to build important tools or algorithms that can help students, can accelerate and improve learning, and help teachers and educators as well. As we're partnering with these different organizations, we're identifying key research questions, we're defining important problem statements. We then try to translate those problem statements into specific machine learning tasks, whether it's automatic grading, labeling, classification, or content recommendation through recommendation engines. We try to see if there's this problem in student learning or in the educational system that we want to solve, what specific machine learning tasks and applications can directly link to that. Once we've identified the machine learning task and we've built the data set to use, we then run a competition where we're crowdsourcing solutions to this problem. So specifically within the context of NLP and large language models, that's where we see this connection really emerge, is that we're crowdsourcing large language model-based solutions to address specific educational problems. To give a specific example of this, I can talk about our flagship project, which was the Feedback Prize. So in the Feedback Prize, we identified a critical problem. Students struggle to write, and they don't receive a lot of feedback on their writing. And this is particularly a problem in the middle school grades and in the high school grades. There's some data showing that very few students graduate from high school as proficient writers. So we identified this problem, and we also identified a machine learning solution that we now see this emergence of automated writing evaluation systems, which are powered by large language models that can look at student writing and that can evaluate the piece of writing for its quality and potentially provide feedback. So with that, we ran 3 different competitions in our series to look at this issue of student writing and assisted feedback. I can go into more details about how these competitions were able to, leverage large language model-based solutions. But at a high level, our 3 competitions looked at 1, building a large language model solution that could identify different components of an argument in a student essay. 2, building a large language model-based solution that could evaluate the quality of these different argumentative components. And then 3, building a large language model that could have a specific focus on language proficiency when it comes to writing by English language learners. These 3 competitions, we were able to crowdsource over 100,000 solutions. We're really excited to report that the winning solutions had accuracy at the level of humans, and the winning solutions were indeed large language model-based solutions. Many of them were actually ensembles of transformer models, which is a popular type of large language model. So just to make this a little bit more practical and concrete of what the Feedback Prize large language models can do, they first can take an essay and break it down into smaller chunks through segmentation. So they take an essay and parse it out into different smaller units that each perform a specific argumentative function in the essay. Then they label those components based on 7 different categories, like a lead, a position or the main thesis statement, claims and pieces of evidence. And then they can also evaluate the quality of these different argumentative elements. They can say, okay, this piece was more effective, or this piece was adequate, or actually this section right here, this piece of evidence was ineffective in supporting the overall argument. So that's just one example of how we're creating data sets and data science challenges to create large language model-based solutions that can perform educational tasks to improve learning. But before we get to that stage of having the large language model-based solution, we believe that a large language model can only be as good as the data that it's trained on, right? So a core component of our work is building specialized high-quality data sets to train these large language models. And because we're publishing them, we believe that the openness of the data set and also the openness of the algorithms, making them open source, ensures that we have transparency, reproducibility, as well as algorithms that can be further analyzed and researched for other issues. So we build these data sets. It's a pretty thorough and comprehensive process, but we try to make sure the data captures different learning and assessment activities. We also prioritize diversity and inclusivity in our data because we really value fairness in our algorithms. So with that being said, When we're looking at these large language model based solutions, we don't merely just, take the large language model with the best score in a competition and then sort of call it a day. We continue to do evaluation because we want these solutions that are being produced in competitions to actually work and be effective in a real classroom setting and in a real learning environment. So our key metrics when we're looking at these large language models are accuracy, efficiency, and fairness. In many of our competitions, we have one going on Kaggle right now. Kaggle is our big platform for running data science competitions. We have this prize incentivized efficiency track. In essence, what we do is when we have an NLP-based competition in particular, we want large language models that are simple, that are fast, but that also have high accuracy. In addition to efficiency, fairness is an increasingly important concern in AI, but is especially important in education as well. So we take a lot of steps to make sure that we're not producing large language models or encouraging the development of large language models that will be biased and disadvantaged historically marginalized students. So in order to do that, we take steps to minimize biases in the data sets through the data collection, as I mentioned earlier. We also take steps in designing competitions that can address algorithmic bias as well. So ultimately, through these data sets and through these data competitions, we're able to then yield large language model-based solutions that we hope product developers or even nonprofit organizations or school agencies can use in their actual tools and platforms. So what we hope to do next as we continue in this work, we try to seek out partners who can use these solutions in their platforms, in their environments. We try to ensure that there's alignment between what the algorithm can do and what specific features or services that a tool developer is trying to provide in their platform and in their environment. And we also can, consult in thinking through what are specific user-centric approaches, what are specific features or functionality that these large language model-based solutions can perform once they're integrated into a product. So that's sort of an overview of how our work kind of intersects with large language models. I think in the last section in talking about product implementation, I think that's where the power and promise of LangChain will really step in thinking about how do we take these sort of, production ready models, but then use it in a tool and in a product application that directly serves the needs of students and teachers. So overall, we believe that open data sets and data science competitions can really promote collaboration and innovation in the field of AI and NLP. So if you're interested in learning more about our work, if you're interested in potential partnership or consulting opportunities, because we have many different competitions we're hoping to launch in the near future. We even have one running right now. Feel free to reach out to us. I have my email address up on the screen and would definitely love to connect and talk more about this work.
Amazing. Thank you so much. That was awesome. Yeah, and as you all know, I wholly subscribe to this view that you have to actually invest in the data sets if you're going to get some of the upside when it comes to some of these applied use cases. So Harrison, why don't we bring you back? And just to start off, it'd be great, just your sort of reaction. You're seeing this space develop really fast on like what do you think the potential is in education, both for LLMs overall, but LangChain, and then some of your sort of off-the-cuff reaction to some of the presentations and ideas of use case and sort of thoughts of the community.
Yeah, absolutely. I actually have two questions that I'd like to get like all panelists' thoughts on as well, and this gets to like my reaction to a lot of them as well. I mean, one is around like I think or actually yes. So I think the thing that starts to become really powerful is connecting language models to other sources of data, whether that be things that people upload or other data sets that are curated or anything like that. Like I think that's one of the, and I think that's one of the areas where LangChain helps out a lot and helps augment just the language models themselves. And so that's, I think that was present in kind of like everyone's presentation. There's another kind of like aspect to that, which I would love to get the panelists' takes on, which is basically personalization of education to specific students. So now different than like someone could upload a textbook, but the way that one student might learn it might be different from the way that another student might learn it. And I think like this is part of the power of generative AI in education is you now can start to have kind of like tailored plans or tailored tutors for particular individual students. And so I'd actually be really curious to hear everyone's kind of like take on that and how they're thinking about that, both in terms of like from a product point of view, like what's the priority of this relative to other things, but then also from a technical point of view, like how exactly do they imagine kind of like implementing this?
Yeah, Joshua, why don't we start with you? What are your thoughts on, like, let's say there was a file that just kept the user history of how they've interacted with Podzy in the past, and one of the LangChain scripts was like, well, review the history before, you know, you serve up the next piece of thing.
Yeah. So I think we've already started trying some personalization, especially with like the tutoring chatbot, like allowing like the prompt for that tutoring chatbot is, you know, given this student's answer as well as like the previous conversations you've had with the student about this specific question, like guide the student in a Socratic manner so that they can like clarify misconceptions, get a deeper understanding of the problem. I think when it comes to personalization, we almost think of it as like a spectrum. Like on one end, you might think of it as just you let the student interact with these large language models, and then that's it. Like you let them kind of go off on the Wild West on their own. I think what we're really interested in doing is involving the teacher when it comes to the personalization aspect. So we find a lot of power in so you mentioned like giving large language models access to external data sources. Like we envision using large language models almost as like a proxy layer between teachers and students. Like we want to direct teachers to what students need to have addressed most urgently at that moment, and then letting the teacher actually step in to decide maybe it is like letting the student interact more with the tutoring chatbot, or maybe the teacher should just directly interact with that student. I think that idea is much more compelling in the short term, especially as we're still dealing with like accuracy and hallucination issues. So I think like part of the reason why we haven't released the chatbot yet is because we're still looking to build in a feature where like teachers can continually monitor these conversations and then step in whenever necessary to be able to like, if necessary, like steer the conversation back on track.
Interesting. Do you imagine doing that like helping, like flagging, like, oh, to the teacher, like automatically, now you should think about stepping in, and like if so, like how do you think about that? Is that just separate like LLM call that's running in the background that's like yes, no for whether to flag to the teacher or something like that?
Yeah, I think so. I think it's like if you can like potentially flag if you notice that the conversation is going off of like what the happy path might be. I think like that's like one example. And I think in general too, like instead of just like individual conversations, like I mentioned, we'd like to explore how we would use LangChain to give the ability for these models to make SQL queries against our database. I think like that's like one area. We're talking to teachers, and I think one area that they consistently give us feedback on is just knowing like there's so much data to actually work through when it comes to student responses. So like how can we actually point them in the right direction given
what are some of the types of questions that they're asking in terms of like or hoping to get out of like the students' responses? Like what types of questions are they asking? Like, is that the main one?
Like addressing potential misconceptions, I think is a big one. Because a lot of times like what might be holding a student back from mastering some concept is just one gap, one like crucial gap. So we can actually direct teachers towards addressing that crucial gap that's prominent across a lot of students. That would be quite powerful and just like a high leverage moment in a classroom.
There's actually some really cool parallels to how we think about like our documentation and our documentation bots to this, right? Like we've wanted to look into this for a while. Like, you know, we have chatbots on the website where people can ask questions, and like, can we use the questions that people are asking to highlight areas where there's just a lot of uncertainty or stuff like that. So maybe it would be cool to collaborate on some stuff there in the future.
For sure,
Neil Heffernan from Assessments has this interesting tool he's built where basically teachers get like this report on the nightly homework, which is the most common wrong answer for their class on the homework assigned. And the teachers love that because, you know, you can only review so much the next day. So if you can point to, hey, this is the thing that people are getting most wrong, then you could say, okay, well, what might be the misconception that's triggering that for the most classmates? And if you can get that in that report before they actually teach the next class, that ends up being quite powerful. Well, on this particular thread, whether Perpetual or Wesley, do you have any additional thoughts either on this question around, you know, additional data calls you might make that might help you personalize or might help you target or might, you know, sort of like things that sort of jump out to you on Harrison's questions? Otherwise, I might sort of go through a couple of the questions that are coming through chat, which have also been great.
Yeah, that's a really exciting area. I think something that's different about our project from Joshua's is since we're working with adult learners, we're kind of assuming minimal engagement from the teacher, and that this tool will be something that's basically plug and play. And in that context, intelligent tutors would be something that would be incredibly useful. It's about 2 steps down the development chain before we get to intelligent tutors, I think. But the types of data that we're collecting, and it's definitely something that we're keeping in mind as something that's going to be part of the project.
Awesome. And Perpetual, anything else you would add on just sort of this question around interesting personalization or other calls? Obviously, I saw some of the questions that come in around what about Spanish and, you know, sort of learners in different contexts, especially when it comes to writing.
Yeah, I can't speak too much from a product point of view. I think maybe I can speak a little bit more. I think on the algorithmic side, I think we've been really excited about the possibilities with recommendation engines and reinforcement learning and building agents that can be intelligent enough to personalize the delivery of content based on the data on user history. So I do echo earlier sentiments there. I did see a question about multilingual abilities with our models. So some of our models do, when we have the opportunity to have data that's representative of different languages. One example, I'll drop a link in the chat. We had a competition recently that focused on recommending content and learning materials for curriculum design or for course design. And so with that, we were able to source learning materials from a platform called Calibri by the organization Learning Equality, which serves students globally, internationally. So whenever there are opportunities to collect data that's representative of different students as well as different languages, it is an exciting opportunity for us.
Can I ask one more question before we jump into some of the user questions?
Oh, yes, please.
So a lot of talk around product design and product UX has been focused on chat and how good chat is as like an interface. And so I guess this is maybe a bit more for Josh and Wesley, but as you guys are thinking about designing your applications, I think both of you mentioned some type of chatbot. How do you view chat in the sense of like product UX? Like, do you think it's good but not great? Do you think it's the ideal one that you'll settle on? Do you already not like it? Like, I'm just curious for your takes on it because I think it's been much discussed.
I think it's good as part of a bigger picture. So for example, like with the chatbots, we've been just like testing internally. And I think if it's too open in terms of like what a student can ask, it again can just get derailed really quickly. Like we saw in some of like the initial beta testing, like students would ask like, "How was your day?" and then the chatbot would respond. So that's like suboptimal. Like we've tried other things like giving specific prompts that they can click on for chatbots. That's great. But what I mean in terms of balance, I think is like it's like useful as a follow-up to specific things that are structured. So for example, like with the teaching assistant, I don't think we envision just like slapping a chatbot onto Podzy and then having teachers ask whatever they want. We think it's much more powerful instead if we use a language model to generate like a maybe end of day report, similar to what Kumar mentioned with assessments and what Neil Heffernan is doing, as well as I think some of the other comments were also talking about like after action for teachers. Those are like really interesting usages. And then like if you want to allow teachers to then ask follow-up questions and like make further queries on top of like what was already presented in a structured way, I think that's a much more effective solution than just being than just like letting them do whatever they want. Yeah.
Wesley, did you have thoughts on this?
Yeah, to piggyback a little bit off of what Perpetual was saying, this isn't a chatbot question, but one area that reinforcement learning I think would be really useful for us is that we have a single summary evaluation tool, but in different contexts, there may be different, different language domains that it might be more or less appropriate for. So allowing teachers or instructors to spot check the results of the scores, and be like, this summary passed, but it obviously shouldn't have passed, and give that a thumbs down, and just kind of continually iterating the model in that way would be something that would be really useful for us and something that's on the horizon. Chatbots we haven't really begun to explore yet, but yeah, they are exciting for sure. Oh.
I mean, the use case that often people cite to me that's not the chatbot use case is some version of a power tool for the instructor, right? It's like Copilot for the teacher, the sentiment engine that goes to the teacher about who's talking, who's doing this, the feedback tool for the tutor.
Yeah.
What are ways to improve the improvement cycle for the instructor about how they manage their time, whether they focus, their teacher moves that they're using, and then what's the right way to randomize instructor to student. So like, what's that assignment system? And can you get greater ROI on that? There's been a bunch of great questions in the chat, some of which we will send on to the individual folks in case they might be able to respond to people directly. One that jumped out to me was one that Bror asked about, to what extent could you, and it builds on Harrison's question, to what extent could you actually use simulated students to practice, to allow instructors to practice in low stake settings, different instructional strategies and others. I don't know if anybody among our panelists has looked at, the idea that these might actually be good teaching environments in addition to instructional environments, direct to student. And I'd be curious if anyone's done any thinking or work on that.
I think it's a good idea.
I have not done any thinking on that from the educational perspective, but the only thing I'll add is like I love the idea because I think it's pretty related to some of like the multi-agent stuff that we did in LangChain, where I mean, if you want to take it even up another level, you could simulate a teacher and a student, and then have the teacher like say, oh, what could the teacher have done better here, and like use that as almost like another way of learning. So I think the idea of having like personalizing and basically incepting like different agents to act in a particular way, whether it's as a student or as a teacher or something like that. Very interesting, but I'm sure Joshua has more relevant things for education to say.
Yeah. Well, I only started thinking about this last week because I saw one of the tools competition that Schmidt Futures and I think Learning Agency are helping running. One of the finalists is actually working on this idea about letting teachers practice, for example, explaining potential misconceptions ahead of time. I think that is one thing that, like, when I was a teacher, I definitely struggled with, because in my mind, I would think like, oh, they didn't understand how to subtract with negative integers. I'll be able to explain that like without much practice and just do it on the spot. But then when you're actually in front of them, you realize all these other misconceptions that might have gotten in the way of them understanding negative integers, that I wish I would, if I had a practice run and gotten those questions ahead of time, I would have been able to structure that lesson in a much more coherent and strategic way. And I think that that is like one powerful way that like large language models can help teachers, because I think it is like very powerful as like a brainstorming partner. Yeah.
Awesome. Well, we're running close to time. What I want to do just to help us close out, I think these questions have been awesome, is invite Anjali onto stage. Anjali actually inspired this original chat in the first place in reaching out to Harrison. And Anjali actually leads one of our programs on benefits access. How do we use these technology tools to increase access for Americans as they apply for benefits? But Anjali, both welcome. Thank you for setting this up. And two, what are some of the things that jump out to you in general from this conversation around both the education use cases, but how it might apply to some of the other ones? And then you can also help close us out.
Thanks, Kumar, and thanks, Harrison, and all of our presenters for making this happen. I think the first thing I'll say is that you should always DM people on Twitter, because this is a great way to get things happening. So in the spirit of that, if there are questions or other follow-ups or ideas that have sparked from this conversation, you should continue the conversation in ways that our team will drop into the chat. And also, if you are on social media, come chat and come talk about what you are building publicly. A couple themes that I heard from today that I think are really exciting and motivating. One is, it is such early days. I feel like we say that a lot, but it's such early days for all of this work. And even though we've been doing, and so many experts in this field have been building this space for so long, there's, in the last 6 months, just so much new technology that has been created. The level of activity that's happened in just the LangChain Discord alone is wild. And so there's a ton of opportunity to do more and to learn really quickly. So I'm inspired by everyone here who is building and tinkering and learning together. The second thing is, I think there are a lot of questions that have come up during this conversation that are super relevant for education and also really, really important for other fields. And what I mean by that is things like how we do summarization, or how we query specific bits of information from large documents and translate that into other languages, or figure out how we're trying to connect many disparate pieces of complex data all together and build agents that can go off and do things that support critical use cases. Those are important for education and also important for topic areas like climate change, or access to government services, or legal aid, or you name it. And so all of the things that you're building and describing in the chat and in these presentations are really important and also applicable for other areas as well, because everyone is asking these same questions. So in the spirit of that, if you're building in the space, or if you're building something that isn't quite education, but somewhere adjacent, reach out, because I think there's a lot of cross-pollination opportunities here. Finally, I'll just offer, if there are specific questions that you have, or follow-ups, or ways that you want to continue to engage or share what you're working on, our team will drop 2 links into the chat. The first is the LangChain Discord. The second is the Learning Engineering Google group, which has thousands of people who are also building in this space. And finally, if there are things that you are working on, I am also happy to chat with anyone at any time and brainstorm with you one-on-one about things that you're building or questions that you're facing. So my link to my Twitter is in the chat now. Feel free to reach out.
Harrison, thank you so much for having me and having all of us here, and for running this great session, and for building this community and the work that you're doing in the open.
Thank you, Kumar, for joining, and thank you, Anjali, for sparking this, and thank you, Joshua and Wesley and Perpetual for joining. This was a blast.
Awesome. Well, we'll see everybody out there.
All right. Bye-bye.